Today's recording will go over Unit 4, Lesson 2, which is page 5 of the note packet. Today's lesson deals with the polygon angle sum theorem. The definition of a polygon is a closed plane figure, and it has at least 3 straight edges. So to the right, 1, 2, 3, 4, 5, is an example of a polygon that has 5 sides. It is a pentagon. A quadrilateral is a polygon. A triangle is a polygon. Anything that is closed with straight edges. We name a polygon by listing its vertices consecutively in a clockwise or counterclockwise direction. So to name the polygon, we need to just list the corners. You can start any place you'd like to, as long as you go in order from where you started. So I could call this polygon D, E, A, B, C. I could start in a different spot. I could start at A, B, C, D, E, as long as all of the vertices are listed. You do not need a triangle or any sort of symbol in the front. Sides are made up of straight edges. They are line segments. So we have line segment AB, BC, CD, DE, and EA. To name the angles, angle A, angle B, angle C, angle D, and angle E. Notation is important so that we can understand that we're talking about the entire closed plane polygon, whether you're talking about a line segment, whether you're talking about an angle, or a vertex is a point. So A, comma B, C, D, and E. And again, we don't need the word point, but you could do it if you'd like to. Next page. You're responsible for knowing all of the names associated with the sides: triangle, quadrilateral, pentagon, hexagon, octagon. Some people will ask, what is a 7-sided figure? It is a heptagon, octagon, nonagon for 9, decagon for 12. I'd have to look it up, but I don't know what it would be for 11. And if you're anything higher than 12, you can just refer to it as by its number of sides. So if it were something that had 20 sides, you'd call it a 20-gon. So we could call something with 11 sides an 11-gon. We don't refer to a quadrilateral as a 4-gon because it actually has a name. So the number followed by the gon is only used for things that don't have a already recognizable name. Define and draw an example for each of the following. Equilateral is where all the angles are equal. An example is a rectangle. A rectangle has all 4 90-degree angles, but no sides. I mean, it has congruent sides, but they're not all congruent. Equilateral is when all of the sides are equal. An example of this could be a rhombus. And then a regular polygon is where you have both equal sides, and we're talking about all equal sides, and equal angles. And again, all of the angles are equal. So an example of this could be a square. Octagons, pentagons all have regular shapes. So we have a regular triangle called an equilateral or equiangular, pentagon, octagon, where all of the interior angles are the same. And where each side is the same as well. Polygon angle sum theorem. Some of you may know this, and it is just a matter of patterning, but this is what allows us to determine how many degrees are inside of a figure. We already know that a triangle has 3 sides and that it has 180 degrees. If we can create triangles within a closed figure, we can multiply the number of triangles in the figure in order to determine the total number of interior measures. So pick a point on your figure and make a diagonal. What we have is that the quadrilateral has two triangles. So 4 sides has 2 triangles. If it has 2 triangles and triangles add up to 180 degrees, then that's the reason why a 4-sided figure has 360 degrees. Pick a point, and it can be any point, and make a diagonal straight across the shape to the opposite side, and there happens to be in a pentagon a second diagonal. 5 sides, we constructed 3 triangles, so 3 times 180 ends up equaling 540. So a pentagon has 540 degrees if you were to add up all the inside angles. So these angles here all add up to 540. A hexagon has 6 sides. Pick any vertex you'd like and go across the figure to each of the other diagonals. We created 1, 2, 3, 4 triangles. If each triangle is 180 degrees, then it ends up equaling 4 times 180, which is 720. This next figure has 7 sides. Pick any side you want to, any vertex, and go across to the opposite vertices. And there happens to be one more here. 1, 2, 3, 4, 5 triangles were created. So if there's 5 triangles, 5 times 180 ends up being 900. And then the last one, an 8-sided figure. Let's see, there's one there. 1, 2, 3, 4, 5, 6. So there ends up being a total of 6 triangles. So 6 triangles have 1,080. So for an 8-sided figure, the total number of degrees on the inside is 1,080. The polygon angle sum theorem, which is at the top of the next page, is the formula that you were able to kind of summarize in the pattern in the table that we just made. What it says is that the sum of the measures of the angles of an n-gon is n minus 2 times 180. If you look back at the page you just did, a 4-sided figure had 2 triangles. It was 2 less. A 5-sided figure had 3 triangles. It was 3 less. 6 had 4. 7 had 5. So if we were to take any closed-sided figure with n number of sides, the pattern is that number of sides minus 2 times 180, and that gives you the total degrees of the inside. So you try. It says find the sum of the measures of the angles of a 15-gon. Well, a 15-gon has 15 sides. 15 minus 2 times 180 gives me 13 times 180. If we were to draw a closed-sided figure with 15 sides and draw all of those diagonals, it would have 13 triangles. So 13 times 180 ends up being 2,340 degrees. This concept can be applied to find the missing angle measure. So the measure of angle y is down here. We don't know it. If this were a triangle, we would add everything up to 180. But because it's a 1, 2, 3, 4, 5 pentagon, a 5-sided figure, 5 minus 2 times 180, ends up being 540. So for a pentagon, I'm adding up all of these angles and setting it equal to 540. So 90 plus 135 plus 90 plus 90. Grab my calculator. So 90 plus 135 plus 90 plus 90 ends up equaling 405 plus that unknown value, subtract from both sides, and you're able to determine the value of x. Well, I guess it's angle y. but you're able to find that missing angle measure. Exterior angles, we have discussed exterior angles with triangles. Exterior angles are formed by the side and its extension. So we have this animation from the other day. We can make them regular or not regular, add as many sides as we want to, but they can go in both clockwise and counterclockwise directions. The other animation that I have shows a car driving, and it shows the exterior angles being formed. So all of those are exterior angles. Draw the exterior angles. You can go in any direction, but you're extending the side. So it can have as many exterior angles as the number of sides that it can have, and they can go either clockwise or counterclockwise. Polygon exterior sum theorem mentions that the angles added up on the outside equal 360, and I think this car does a good job of showing that as it goes around the outside, let's play it one more time, it shows those angles. Angle A is 80, angle B, angle C, and it's going all the way around, and when we go all the way around, things add up to 360 degrees. So take a calculator if you'd like to and add those up. This part down here is just talking about for the pentagon, because the pentagon has 5 sides, it has 5 exterior angles. So if it were for a hexagon, there'd be a 6th angle, octagon, there'd be an 8th angle, so on and so forth. Find the measure of the interior angle of a decagon. I want the measure of a single and interior angle. Well, a decagon has 10 sides. 10 minus 2 times 180 tells me that the entire decagon has 1,440 degrees in it total. Well, if a decagon is made up of 10 sides and 10 angles, and if it's regular, all those angles are the same, so 440 divided by 10 is going to give me the measure of just one of those angles, so it's 144 degrees. I'd like you to go ahead and try letter B. Letter C says find the measure of an exterior angle of a pentagon. Well, the exterior angle is formed by that extension. We know that a pentagon has 5 exterior angles if I went all the way around it. So all the way around is always going to be 360. If it's regular, that means that each of these angles are the exact same measurement. So 360 divided by 5 tells me that each angle on the outside is 72 degrees. And let me show you the animation here real quick. So a 5-sided figure, if it's regular, each of the angles is 72. And this is neat because it allows you to change the sides. That is all for today. Rewatch the video if needed. The links to the animations will be found below the video. Thank you.